Hi, hello, welcome back, students of class 11. We are in lecture 2. In this lecture, we are going to discuss few concepts which are in chapter motion in a straight line. So first concept what we are going to see is speed. What is meant by speed? So speed is nothing but, consider there is a body which is starting its journey from A, then it went to B, then again it went to C, then to D, and so on. And to travel from A to B, it will travel some distance. It will take some time. So speed is nothing but distance traveled by a body in time. So in certain time. So distance traveled by the body and upon time taken, that is nothing but speed. That is a formula we are using. And shortcut if you can write as S is equal to D by T. S stands for speed, D stands for distance, T stands for time. That is a formula. And for every physical quantity, there is SI unit. SI unit of speed is meter per second. You can write either meter per second or you can write it as meter S to the power of -1 second inverse. This is SI unit. After solving few numerical problems, you might write answer like speed is equal to 2 meter per second. Speed is equal to 6.5 meter per second, etc. Like that you can mention. Speed is equal to distance traveled by the body in certain time taken. Then in speed, there are three types of speeds you need to learn: uniform speed, variable speed, average speed, instantaneous speed. Let us see what is meant by uniform speed. In the name itself, you have uniform. If a body or an object is said to be in uniform speed, if it covers equal distances in equal intervals of time. For example, body which is starting its journey at A and it is going to B, to C, to D. For example, from A to B, 2 meter distance, B to C, 2 meter distance, C to D, 2 meter distance. If it is covering 2 meters in 1 second, again this 2 meters in 1 second, 2 meters in 1 second. From this, what we can tell, body is traveling or body is covering equal distance, equal distances in equal intervals of time. In equal intervals of time. That is nothing but uniform speed. While coming to variable speed or non-uniform speed also you can call. If a body is covering unequal distances in equal intervals of time, time cannot be unequal. Consider body is starting at A, it is going to B, it is covering 2 meters in 1 second. Again from B to C it is covering 1 meter in 1 second. Again C to D it is going 4 meters in 1 second. You see, time intervals are same. In 1 second, from A to B it is covering 2 meters, BC it is covering 1 meter, then again it is covering 4 meters. So body is traveling unequal distances, but time interval will be equal. Such type of speed is nothing but variable speed or non-uniform speed and average speed. Here, maximum we are taking average speed only. For example, your school bus. School bus might start from school and it will reach your house. Consider evening times after leaving the school. You will be boarding school bus or your father's mother's vehicle. You will start from school and you will reach house. While you are reaching house, it might take many turns and it will go in some streets and highway, everything it will cross and at last it will come to your house. Here, from this point to this point, it might travel some distance, certain time. From here to here, it will travel some distance in some time. Again, from here to here, distance, time. Like that, in every path, it will take different distances and different times it will take. So, to reach your house, your school bus or your vehicle will travel multiple distances and different amounts of time. So, to reach your house, you are calculating average speed. What is average speed? Total distance traveled by a body in total time. Maybe in 1 hour, it might travel 25 kilometers. So at the time, what you can write speed, average speed is equal to 25 kilometers per hour. With the 25 kilometers per hour, you have traveled. Or you can calculate like from A to B, you travel 2 kilometers. Again, from B to C, you traveled 4 kilometers. And A to B, you can take 1 hour. B to C, other 1 hour. What is your average speed? Speed average is equal to what is total distance traveled? 2 kilometer plus 4 kilometer upon what is total time taken? 1 hour plus 1 hour, 1 plus 1, that is equal to 4 plus 2, 6 upon 1 plus 1, 2, 2 ones, 2 threes. Now what is average speed of the vehicle? You can tell 3 kilometer per hour. With the 3 kilometer per hour, you have traveled total 6 kilometers. So that you will reach with the speed of 3 kilometer per hour. Like that, you can take average speed. So average speed is total distance traveled by a body upon total time taken by a body. Now, instantaneous speed. What is meant by instantaneous speed? It is very simple. Speed of an object at any particular instant of time. For example, body is starting at A, it will go to B with a speed 2 kilometer per hour. Again, it will reach C with 5 kilometer per hour, and it will reach D with 1 kilometer per hour. Now, if I ask you what is average speed, you can calculate. If I ask you what is the speed at C, or for example from A to B, it has taken T is equal to 1 second. Here T is equal to 2 seconds. T is equal to third second or 3 seconds. Now, if I ask you what is the speed of an object at second, you can tell speed is 5 kilometer per hour because I am asking at that particular instant. If I ask what is the speed of an object at third second, you can tell it is 1 kilometer per hour. So speed at particular instant is known as instantaneous speed. Now, consider body is traveling delta x, it is a small distance, and it is taking delta t. Whenever you see this delta, you can call it as small change or small. Okay, so body is traveling delta x distance in delta time. And what is speed? We know speed is equal to distance by time. Here distance we are taking it as delta x upon time we are taking it as delta t. Delta x by delta t. Now we are asking speed at a particular interval of time. So we are limiting time to 0 seconds because at that particular time will be 0. So you can write it as speed v is equal to distance delta x upon time delta t. So delta x is also written as dx delta d, this delta as d dt, dx by dt. It is a first differentiation. Next, we are limiting limits. We are applying limits to that, limiting time value to 0. Why we are limiting time value to 0? Because we are calculating or we are finding speed at a particular time. At particular time, time will be 0. So this will be the formula for instantaneous speed. So speed is equal to delta x by delta t, limits delta t to 0. We are limiting it to 0. So that is equal to dx by dt, like that. And speedometer is the instrument which is used to measure instantaneous speed at any instant. If you see vehicles, there will be speedometer where that needle, it will be showing 10 kilometer per hour, 20, 30, 40, like that now. So when you are traveling, if it is showing 40, so it is like a body, that bike or car is traveling with 40 kilometer per hour speed at a particular instant. After 2 seconds, if you see, it can be 60. After 3 seconds, if you see, it will be 30. So it will be changing. This speedometer will be changing. And here you can find a few digits. So how much distance you have traveled. So here it will be not 2, 4, 5, 1. So these many kilometers you have traveled. So instrument which is measuring distance is known as odometer. And device which is measuring or calculating the speed, or it is showing instantaneous speed, it is known as speedometer. So these are the three types of speeds. Moving to next concept, different formulas. Okay, let us see what are the different formulas will be used so that you can solve numerical problems. Videos also will be uploaded regarding solving numerical problems. Let us complete all the theory first. After completion of theory, I'll teach all the numerical problems also. Okay, number one. Try to note down all these formulas in your book. And if you want, you can take screenshot also. So we know speed is equal to distance by time. Second formula, instantaneous speed. So speed also represented with letter V. Why we will represent with V, that also I'll explain you after explaining velocity. Okay. So what is the formula? Limit. We are limiting time delta t to 0. And we know it is delta x, distance by time delta t, which is nothing but dx by dt, differentiation of this x. Okay. Next, third one. Consider, okay, third formula is average speed. Yes, AVG. Average speed is total distance traveled by a body upon total time taken by the body for the traveling. Next, fourth condition. See, if a body is traveling different distances, okay, body is traveling different distances and it is traveling these different distances with different speeds. So try to understand, don't get confused. Here you see the formula speed is equal to distance by time. In this there are three quantities: speed, distance, time. If you have any two, it is easy to find the third one. Now you see they are telling body is traveling with different distances, in different distances. For example, distance like d1, d2, d3 distances it is traveling with the different speeds. d1 distance it is traveling with s1 speed, d2 distance it is traveling with s2 speed, d3 difference it is traveling with s3 speed. So these are distances, these are speeds. Here what is not mentioned? Time is not mentioned. So speed is mentioned, distance is mentioned, and time is not mentioned. Now how to find out average speed? Okay, average speed, yes, AVG is equal to, what is the total distance? D1 plus D2 plus D3 by, we need time, that is T1 plus T2 plus T3, total time. But here unfortunately there is no time. Then how to find? So from this formula, speed is equal to distance upon time. There is no time, send the time that side, it becomes time is equal to distance upon speed. Now we know distance d1 and we know speeds s1. Now instead of t, you can write it as d1 by speed s1 plus, instead of this t2, you can write it as d2 by s2. Instead of this t3, you can write d3 by s3. D is distance, s is speed. Now it becomes speed average, or average speed is equal to, in numerator we can find d1 plus d2 plus d3, and in denominator instead of time, instead of t1 we wrote distance by time, d1 by s1 plus d2 by s2 plus d3 by s3. So these are the different formulas what we can make it. Now other condition, consider body is traveling with equal distances. Consider d1 is nothing but d2. So it is traveling equal distances. At the same time, it is going with different speeds. Speed s1 and another speed s2. So it is traveling d1 distance with s1 speed, d2 distance with s2 speed, but the condition is d1 is equal to d2. So when d1 is equal to d2, d1 also you can mention it as d, just normal d. d2 also you can mention it as d. Two same distances. Now What is average speed? S AVG is equal to, we know it is total distance t1 plus t2 by time t1 plus t2. Now here also condition we have distances, speed. What they didn't mention? Time they didn't mention. Okay, let us substitute other values. What is d1? We have taken it as d, plus what is d2? Here also we have taken it as d, because d1 d2 both are same, upon time. So we know now speed is equal to distance by time. If you need time, send the time that side. T is equal to distance by speed. Now instead of t1, you can write distance by speed. Instead of t2, you can write distance by speed. What is the distance? It is d, upon what is the speed? It is s1. Well, coming to second, distance is d, speed is s2. Now instead of t1, what you can write? D by s1, plus instead of d2, you can write, instead of t2, you can write d by s2. Now d plus d, 2d upon, if you take d as common, it becomes 1 by s1 plus 1 by s2. In numerator, denominator d is cancelled. At last, we are going to get 2 upon 1 by s1 plus 1 by s2. Now 1 by s1, 1 by s2, you can take LCM. 1 by s1 plus 1 by s2. LCM is s1, s2, numerator s1 plus s2, or s2 plus s1. s2 plus s1. Either s2 plus s1 or s1 plus s2, both are same. This you substitute here in this place. If you substitute, we are going to get in numerator 2 upon s1 plus s2, or s2 plus s1, both are same, upon s1, s2. This entire denominator, if you send it over, so it becomes this denominator s1, s2 multiplied with 2 by s1 plus s2. Okay, so here another thing, speed can be mentioned with letter S or V. In your 11th class, whatever material you take, they will be mentioning speed with the letter V. So from now onwards, instead of S, let us mention it as V. V stands for velocity. Velocity speeds both are same. So whenever you have S, you substitute as V, then S AVG, average speed, or V AVG, average speed is equal to, okay, here let me write, V AVG, average speed is equal to 2 V1 V2 by V1 plus V2. So this is the formula, 2 V1 V2 by V1 plus V2. So these are the formulas you need to remember. Then another condition, consider a body is moving with different speeds in different times. Now, what will be the formula? See, we know speed is equal to distance by time. From this, t is equal to distance by speed. Again from this, distance t is equal to speed into time. Now body is moving with different speeds. Different speeds we can take it as v1, v2, v3, etc. And different time intervals. And different time intervals t1, t2, t3. Now what will be the average speed? We know SAVG or VAVG, average speed is equal to total distance, S1 plus S2 plus S3. Don't get confused. S is not speed. Now S is distance by total time. T1 plus T2 plus T3. Now what is distance? Distance is equal to speed into time. So distance S is equal to speed v into time. Okay, now instead of s1 you can substitute v1 t1 plus, instead of s2 you can substitute v2 t2 plus, instead of s3 you can substitute v3 t3 upon time t1 plus t2 plus t3. So these are the different formulas you need to remember. Next topic is velocity. What is meant by velocity? Already we know speed is equal to distance by time. Now velocity v is equal to displacement by time. Now if you can remember, I told distance can be represented with the letter d and displacement is represented with the letter s. But in this situation, whenever we are seeing distances, they are representing distance, they are representing with letter s. Why? See, in a condition, body is traveling from A to B in this direction. For example, 2 meters. Now, if they ask what is the distance traveled by the body, you will tell it is 2 meters. If I ask what is displacement of the body, we know displacement, it is a straight line drawn between initial and the final point. Now, if you draw a straight line, what is the length? It is 2 meters. So, displacement also 2 meters. When a body is going in straight line, distance and displacement both are same. So that only distance or displacement, you are mentioning it with the symbol S. So from now onwards, if any body or any numerical problem, if they are giving body is going in straight line, either distance or displacement, take it as S. Now you see, distance is equal, speed is equal to distance by time, velocity is equal to displacement by time. As we discussed, d is nothing but s. If you substitute s in place of d, it becomes s by t. Here you see it is s by t, here also s by t. So from this what we can tell, speed and velocities both are same if a body is going in straight line. Isn't it? So when body is going in straight line, distance is equal to displacement. At the same time, speed is equal to velocity. So that from now onwards, distance in the sense s, speed in the sense v. Now, speed we know distance by time, velocity is nothing but displacement by time. And same like units of speed, velocity also has the unit of meter per second. So for speed, SI unit is meter per second. For velocity also, SI unit is meter per second. This can be written as m is to the power of minus 1. Then same uniform speed, variable speed, average speed, and instantaneous speed. What is uniform speed? Body is said to be moving with uniform velocity if it covers equal displacements in equal intervals of time. So uniform velocity in the sense it has to cover equal displacements s1, s2, s3, all these equal displacements in equal intervals of time, t1 plus t2 plus t3, or simply to say same speed what we have studied, same thing, a, b, c. From A to B it is traveling 2 meter, B to C it is traveling 2 meter in 1 second. So now we can call body is traveling with equal displacements. And uniform speed, uniform velocity both are same. Uniform speed, uniform velocity both are same. What is the condition? Body should travel in straight line. Now, variable velocity or non-uniform velocity, if it is traveling variable velocity, so either speed changes or direction of the motion changes, or both can change with time. So it should not travel. S1 should not be equal to S2, which should not be equal to S3. So it has to be changed. Unequal displacements in equal intervals of time. Average velocity, same like average speed, it is total displacement in total time. This one. Average velocity is equal to total displacement, total time. And the same instantaneous velocity, velocity at particular instant of time. Now, for this average velocity, there is another formula. So, this also you should remember. Consider body is starting at origin, and at first instant, body is at x1 when time is equal to 0. And body is traveling from x1 to x2, from x1 to x2. That is the position. So, here x is position. Body is traveling from x1 to x2. and time when time is equal to 1 second. Again, body is traveling to x3 when time is 2 seconds. Now, if I ask what is the average velocity in between time intervals t is equal to 0 and t is equal to 1. In between these two time intervals, what is the average speed? Sorry, average velocity. V AVG is equal to final displacement or final point minus initial displacement or initial point or initial position. Okay, final position minus initial position upon final time minus initial time. Now, if you see, what will be the formula? V is equal to okay. So V AVG is equal to final displacement. If you are taking condition only from x1, x2, this is the condition you are taking. What is the final point? X2 minus what is initial point? X1 upon at x2. What is the time? Here you can take it as t1, this as t2, this as t3. So it will be t2 minus t1. If I ask you what is the condition in between time intervals? In between time intervals, T3 and T2 or T2 and T3. Now you can write it as VAVG is equal to So T2, T3, this is the condition. In this condition, what is the final point? X3 minus what is the initial point? X2 upon at X3, what is the time? T3 minus X2, T2. Like that, we are taking the average velocity formula. And at last, we have instantaneous velocity. What is instantaneous velocity? Velocity at particular instant of time. So same, velocity is equal to displacement by time. Displacement is delta x, small intervals of displacement in small intervals of time, delta x. So velocity, instantaneous velocity is equal to delta x, small change in the displacement upon small change in time, which is nothing but dx by dt, where you are limiting time value delta t to 0. Why we are limiting to 0? Because we are calculating or we are measuring instantaneous, means at the particular instant of time. That is the thing. No, you see average speed. Average speed is nothing but total distance in total time. What is average velocity? Total displacement in total time. These are the two formulas you need to remember. Yeah. When object moves along straight line and in the same direction. So total path length is equal to total magnitude and displacement. So that only average speed is equal to average velocity. So not only average speed is equal to velocity, average speed is equal to average velocity, uniform speed is equal to uniform velocity, everything same. So from now onwards, distance or displacement, both will be mentioned with letter S. Speed or velocity, both will be mentioned with letter V, small v. Okay. Then after that, last concept in this video, that is uniform and non-uniform motions. Okay, what is uniform motion? An object is said to be in uniform motion if it covers equal distance in equal intervals of time. So body should cover equal distances. That is known as uniform motion. And not only equal distance, equal speed also, equal velocities also. That is uniform motion. And non-uniform motion, if a body is traveling unequal distances in equal intervals of time. That is. So here there is another derivation also you see, kinematic formula, which you are going to derive in further classes, which you have studied in your 9th class. V is equal to U plus AT, S is equal to UT plus half AT square, V square minus U square is equal to 2AS. So all these equations of motion we are going to derive in further classes. So these are the concepts which you have studied in this video. uniform motion, non-uniform motion, and here you can see there are few important features of non-uniform motion. So first one, the velocity in uniform motion does not depend on origin of choice. So whatever it may be the origin, it will be uniform motion, uniform motion. It doesn't depend on origin, whether it can start from here or it can start from here, it can start from here. The velocity in uniform motion does not depend on choice of time interval also. Whatever, you can calculate from t1 to t2, or you can calculate from t2 to t3, etc., etc., etc. For uniform motion along a straight line in the same direction, magnitude of displacement is equal to actual distance. So distance will be equal to displacement when body is traveling in straight line. Velocity is positive if object moving towards the right. So consider this is the graph where x-axis and this one is x dash axis. If a body is traveling towards right, so all we are taking it as positive. If body is traveling towards left, that displacement we are taking it as negative. For an object in uniform motion, no force is required to maintain the motion because already motion is uniform. It is not increasing. It is not increasing in speed, not increasing in velocity, so that no extra force is required. In uniform motion, the instantaneous velocity is equal to average velocity of all the times because velocity remains constant. So in uniform motion, instantaneous speed is equal to average speed. Instantaneous speed is equal to average speed. Instantaneous velocity is nothing but is equal to average velocity when body is in uniform motion. So these are the points you have to remember. So in this video, we have discussed about speed, different types of speed, uniform speed, non-uniform speed, average speed, instantaneous speed. Then velocity is equal to displacement by time, distance, speed is equal to distance by time. And uniform velocity, non-uniform velocity, instantaneous velocity. Then uniform motion, non-uniform motion. So these are the concepts which you have covered in your video. So in next video, we are going to see different types of concepts.